All right, welcome to The Explainer. Today, we are diving headfirst into a model of reality that might just, well, completely flip the way you think about everything. We're going on a journey to explore a new structure for existence itself, one that completely reframes our ideas of time, space, and even what it means to be. So let me just throw this out there right from the start. A pretty wild question for you. What if your life, your entire life, from the moment you were born to the moment you die, isn't a journey you're taking through time? What if it's something that already exists in its entirety all at once? Well, in the model we're exploring today, that's exactly what it is. Your whole history isn't a story that's being written. No, it's a finished object. To get your head around this, picture reality as this infinite stack of paper, right? Where each single sheet is one moment in time. Your life, then, is this continuous thread that passes through the entire stack, a single, unbroken line from your first moment to your last. And this thread isn't just some made-up concept for our explainer. It has a real name in physics. It's called a world line. It's basically the path of any object, a tiny particle, you, me, a whole planet, through what we call four-dimensional space-time. So it's not just about where something is, it's its entire history, past, present, future, all of it mapped out as one single thing. Right. Section 1. A thread through space-time. And like I said, this isn't just philosophy. The whole world line idea has some serious roots in modern physics. So let's take a quick look at where it all started. So you got to go back to 1908. A mathematician named Hermann Minkowski is trying to wrap his head around Einstein's new theory of relativity. And he has this brilliant insight, this aha moment. He realized you should treat time as a fourth dimension, totally inseparable from the three dimensions of space. In this new, unified spacetime, an object's history suddenly becomes this static path, and that's what he called a world line. Nowadays, we've taken that idea and run with it, using it to describe the history of basically any system you can think of. Okay, Section 2, the grammar of reality. So, if all of existence is just a bunch of these world line threads, what keeps it all from being just a random, chaotic mess, right? What makes sure that these histories actually make sense? The answer lies in what this model calls the rules of coherence. And the best way to think about this is like grammar, you know? Grammar doesn't write a sentence for you, but it tells you which words fit together to mean something and which are just, gibberish. These rules work the same way for reality, dictating which events can follow each other to form a valid, self-consistent history. And here's a perfect physical example of a rule like that. Fleming's left-hand rule. Now look at this. The direction of the force isn't just random, right? It's completely dictated by the relationship between the current and the magnetic field. It has to be that way. This fixed relationship is like a grammatical rule for physics, making sure you get a consistent, coherent result every single time. Section 3. From particle to universe. So, okay, we've got these threads, these world lines, and they're governed by a set of rules. Now, let's see how this whole thing scales. We're going to zoom out, from the unbelievably small all the way to the unimaginably large. So let's start at the absolute ground floor. At the most fundamental level you can imagine, you've got the world line of a single particle, say an electron. It's just a simple, one-dimensional thread tracing its path. This is the most basic strand you can get in the entire fabric of reality. Okay, now let's zoom out to our scale. To us, we aren't just one simple thread. Oh no, we are an incredibly intricate pattern woven from countless intersecting world lines. And what's really wild is that these patterns can fold back on themselves, creating what's called a self-referential structure. And what is that? It's a system complex enough to become aware that it exists. It's consciousness. And now for the biggest leap of all. Let's zoom out as far as we can go. At this grandest scale, an entire universe has its own world line. Think about that. It's this huge metastructure. It's the complete history that contains every single particle, every star, every galaxy, every single conscious observer. Everything. It's the ultimate rope, woven from all the other threads combined. Okay, Section 4, the ultimate fractal pattern. So this scaling thing we just did, from particle to person to universe, that's not just a coincidence. It's pointing to something bigger, a final unifying idea that connects all these different levels of reality. And this idea is called the principle of self-similarity. Basically, it's proposing that the very structure of reality is a fractal. So, what does that even mean? It means the pattern repeats. The relationship a single particle has to its universe is a mirror image of the relationship that our entire universe has to some even grander, all-encompassing reality. And this idea of self-similarity, it's not just some abstract thing. We see these kinds of fractal patterns literally everywhere in nature. Just look at the way lightning branches out. It looks a lot like the way a tree grows its branches, or how a river delta forms. Think about a snowflake, how its crystalline structure just repeats and repeats at different scales. It really suggests that this is just a natural, maybe even an efficient way for the universe to build itself. Now, to really understand how this fractal reality could actually work, we need to bring in an idea from one of the absolute giants of 20th century physics, Richard Feynman. And this guy had a truly mind-bending way of seeing the quantum world. Just listen to this. He said that a particle doesn't just take one path to get from point A to point B. No, it takes every possible path, all at the same time. Okay, so this is the math behind that crazy idea. It's called Feynman's path integral, but don't worry about the equation. Focus on the concept, because it's incredible. The single path we actually see a particle take is basically the result of a vote. Imagine each possible path is a little wave in a pond. Most of those waves just crash into each other and cancel themselves out. But a few of them, the most efficient paths, they line up just right, they reinforce each other, and they create one strong, clear path. The reality we actually observe is the winner of that vote. It's the consensus that emerges from infinite possibilities. All right, so just let that sink in. We have this powerful idea that a single stable reality for one tiny particle emerges from a sum of all its possible histories. So what happens if we take that exact same logic and apply it to the biggest thing we can possibly imagine? Well, what you get is the sum over universes. We're just scaling up Feynman's logic. We imagine that every single possible universe exists as a potential history. Now, most of them, the ones with unstable or just nonsensical physical laws, they're like those chaotic waves in the pond. They interfere with each other and just fade away into nothing. But the universes with stable, consistent laws, universes like ours, they reinforce each other. They build each other up, and they emerge as a strong, persistent reality. And this brings us to a final, pretty breathtaking conclusion. Our universe, with all its specific laws, its beautiful complexity, everything in it, it exists because it is a stable mode of constructive interference. It's a strong, harmonious wave that has managed to emerge from an infinite churning ocean of cosmic possibility. Which, of course, leaves us with one last massive question to chew on. We've gone from a single particle all the way up to a whole universe. If this model is right, if reality really is a fractal pattern that just keeps repeating, then what lies one level deeper? What is the grand structure that our entire multiverse is just one single tiny piece of? Thanks for joining us on The Explainer.